Okay, so here's the design of a cohort study. So we have a defined study population that has no disease, and then we divide the population into those who were exposed, have been exposed to the risk factor or protective factor we're interested in, and those who were not exposed. And then we follow them over time, and then we note whether they develop the disease or not. So the outcome in the cohort design is relative risk. So we can calculate relative risk because we have incidence in exposed and unexposed. So we calculate the incidence in exposed, which is those who develop the disease over the total number of people who were exposed, and then we also do the incidence in unexposed, which is developing the disease over the total number of unexposed. And so then, of course, relative risk is just the incidence in the exposed group over the incidence in the unexposed group. And unlike the case control study, we can measure incidence because we're at the beginning of the study, nobody had the disease. And so then we are tracking people over time and we see exactly when they develop the disease. And so usually a cohort study takes place over a certain amount of time. Unlike a cross-sectional study, which has a similar design, but the cross-sectional study is just one single point in time. So the following over time between exposure and development of the disease is the key characteristic of the cohort study. So this just shows the same thing in a different way. So we have all our people that were in our defined study population. We sort them into those who are exposed. So in this case, the orange is the exposure, and those who weren't, and then we just track them over time and see who gets the disease. And we see whether more people in the exposed group get the disease than in the non-exposed group. And so one thing this shows also is that usually in a cohort study you can measure multiple exposures. And so if you consider like the black figures to have one exposure in common, and so all the colors represent different exposures. This is the case in a cohort study. You have you can measure multiple things. Since it's expensive, you're following people over a long time, so you measure lots and lots of variables. And then you can track all those variables and see how those different variables are associated with the outcome. So that's another benefit of the cohort design. You can look at multiple outcomes, which you can as well with the case control and the cross-sectional study, but not so much with the randomized controlled trial, since you're only intervening on one variable usually. So remember, when we were looking at cross-sectional studies, we looked at the study that explores the cross-sectional relationship between metabolic syndrome and screen time. And the question that we're interested in is whether sedentary behavior may cause metabolic syndrome. And so an incorrect read of this graph would suggest that metabolic syndrome does cause, extra screen time. Screen time is related or does cause metabolic syndrome. However, as we discussed before, we can't make that inference that the screen time is what causes the metabolic syndrome, because we are looking at prevalent metabolic syndrome rather than incident metabolic syndrome. And as we remember, we cannot make judgments of causality based on prevalence data. We need incidence data to do that. So let's look at a cohort study that addresses a similar question. Okay, on the right you see the results from a study that looked at the longitudinal relationship between screen time and mortality. So this study was done on residents of Norfolk in the UK, and these participants were aged 45 to 79, and so they followed them. They assessed their screen time in about 1998 or 2000, and then they followed them through 2009. So it's roughly 10 years of follow-up. And so they tracked the number of people who died in that time span. And then they looked at the relationship between mortality and the number of hours of TV that they reported watching in around 2000. And so this shows, this provides good evidence for causality, because we know that the TV time measurement occurred probably pretty far ahead of the mortality. And so this relationship, we can be sure that the TV time at least preceded the mortality. And so then controlling for other variables, as they did in this study, it suggests that there is a relationship between those two variables. Similarly, we looked at this cross-sectional study looking at the relationship between diabetes and obesity. So if we were interested in whether obesity causes diabetes, which of course we are, this doesn't really tell us. It tells us there's a relationship, but it doesn't tell us for sure that there's a causal relationship. And again, because this is a cross-sectional study, it was done at a single time point, and the measure in the study is prevalent diabetes. And again, on the right, we see a study, a cohort study that looks at the same thing, incident cases of diabetes over the course of 12 years as a function of BMI of the participants. So these data are from the cardiovascular health study, which is a large cohort study, and it's adults that are 65 and older, and they started the study in 1990, and it's 5,200 adults. And so the people who had diabetes at that time, when they started the study, were not included in this particular study. And then for the people that were in the study, they did a clinical exam every year and tested blood sugar. And so they were tracking whether every year whether people had developed diabetes. And so they followed people for 12 years. And then this shows the results. So as a function of the participants' BMI. So it shows that the people who had the higher BMI were much more likely to develop diabetes. So this provides much stronger support that there's a causal relationship between obesity and diabetes, that obesity causes diabetes because it precedes diabetes, number one, and also there's a dose-response relationship. So the higher the BMI, the higher the number of incident cases of diabetes. And then it also meets other criteria, Bradford-Hill criteria that we discussed before, because there's a plausible biological explanation for why diabetes might be caused by obesity. Another thing to note is that a cohort study like this one, the cardiovascular health study, can also look at multiple outcomes. So we can look at the relationship between obesity and cardiovascular disease, obesity and many other different conditions, anything that happened to be measured in the study. So multiple outcomes can be explored with a cohort, as well as multiple exposures, which we already talked about. So in this paper, I'm not showing you the data, but they also looked at the relationship between fat mass and diabetes, and some other variables in diabetes. So that's another benefit of cohort studies, is they can look at multiple outcomes and multiple exposures. So some of the benefits, again, of cohort studies, just to review, they can measure multiple outcomes and multiple exposures, and they actually capture incidence data, which is important to establishing causality. There are also limitations to cohort studies. So first of all, they're very expensive because you're tracking a lot of people for a long period of time. Secondly, while a long follow-up has advantages, it also has a disadvantage that you can lose people to follow-up. So if dropout from the study is related to the study income, this might create the study outcome and or the exposure, this compromises the study because you may have differential dropout in each arm, and therefore it compromises your ability to see the true relationship between the exposure and the outcome.